Hello everyone, today we'll see about the decision tree. So you can see here I have imported pandas for data frames, numpys for arrays, and this pre-processing is for normalizing the data. Matplot is for visualizing the data. So here I printed, this is the sample data I have chosen as I have chosen diabetes as my data set. This is a sample data of my data set, and here as we can't visualize as I have so many classes in my data set, you can see I can't visualize we can't visualize every single class. So I thought of showing the data in 2D. So I have chosen two variables like blood pressure and BMI, and this is my class label, the output. And here the output variables are printed of my output variables of my class label are printed. Here I have imported a train test split, which will split the data x10, x test, y train, y test, and I have taken a testing I have taken 25% for testing and 75% for training. So here I have imported standard scaler. Normally we have this is used for uh, like normalizing the data. So now we have other scalars also, like min max scalar. Here we have imported a decision tree scalar, and the criteria I'm taking is entropy. Using this entropy calculation, I'll be building a decision tree here. So here you can see using a predict model for X test, and here I have imported a confusion matrix which will give me a confusion matrix. And here you can see this is a data I have given for matplot, that is visualizing my data. So color map, and I have here you can see red and blue are the assigned colors, 75% for trained data. So this is for trained data, we all know that. So red and blue are the assigned this thing. So training data, I have title I have given is decision tree classifier. Training data, so the variables I have took is blood pressure and BMI. So you can see here the decision tree is built and shown between BMI and blood pressure. Here for testing data also we have assigned red and blue colors. The testing labels are age and insulin. So this is decision tree decision tree between insulin and age. So along with the decision tree, we also will see the logistic and nearby algorithms also. So you can see here I have imported pandas, numpys, pandas for data frames, numpys for arrays, and the data set I have chosen is diabetes, and these are my class, and this will be my class label. Here this is null is used to check whether any class of my data set have a null set or a null data. So you can see we got all zeros, so there is no null set in our data. We are ready to proceed now. So this is again the output of only the class label. So this is the this is to get the dummies if you have in your class, but we don't have it. So here I have imported min max scalar this way to minimize my data. Here so you can see here we have minimized the data. Here is the output of minimization. Here we have imported train test split. So X train, X test, Y train, and Y test. Logistic. So now firstly we are gonna import logistic regression. So here the log model logistic regression. So this will give you the normal, like what will be printed if the normal how the X train and Y train will be fitted in the log model. So here the coefficients of log model, intercept of a log model, and this prediction for X train and X test. Here I have imported accuracy score. So Y train and a prediction. Y train and prediction will be with X train. So the accuracy score will be this, and a Y test and a prediction of X test will be 0.6785. So these two are accuracy scores for Y train and Y test. So here I have imported confusion matrix, which will give you a confusion matrix between Y train and a prediction. You can also have a confusion matrix between Y test and a prediction also. So now we'll go for a Navie bias algorithm. So you can see I have imported Gaussian NB. So the model Gaussian NB. So you all know that Navie bias is used for classification. So this model here it is predicted for X train, and Navie predict is like this is the output of our prediction. So log model predict is for X test. Here we have done for Y test. For X train, this is for X test. So accuracy for Y test is 0.6785714285714286, and accuracy score for Y train and Navie predict is 0.7820686956522174. So you can see here we have taken only the prediction. Here we have taken Navie predict. You can see the difference in the accuracies. This is just 0.6 and here is 0.97. So that is it. I have explained three algorithms in this video: the decision tree, logistic, regression, and Navie bias. If you have doubts, comment in the comment section, and thank you.